Alright, so we are here with Mathematics Higher Level Paper 2 Khomas Region August 2020 exam, the higher level exam. And today we're looking at question 4 and question 5. Okay, on the axis below, sketch the graph of y equals 2 cos 3x minus 1 from negative 90 to 90 as indicated here. Okay, so first thing I'm going to do is I'm going to say, well, what does my normal cos graph look like? So we've got y equals a cos b x plus p plus q. Okay, so in this case we've got everything except for the p value here. So we've got a equals some value times cos x plus 1. Okay, so first y equals cos x. What does that look like? So cos of 0 equals 1, then cos of 90 equals 0, cos of negative 90 equals 0. So those are the values that we have here to start with. Then we're going to start producing these values and see how that affects the graph. Okay, so let's start with the 2 in front. So we've got 2 cos x. So what does that do? We multiply every y value by 2. So 1 times 2 is 2. 90 or 0 times 2 is 0. 0 times 2 is 0. So the y values we multiply by 2. Then let's have a look at the next one. That'll be a 3 here. So cos 3x. So what we do there is we divide each x value by 3. So negative 90 divided by 3 is negative 30. 0 divided by 3 is 0. 90 divided by 3 is 30. And then finally, what else do we have here? We've got a minus 1. So that means we shift every y value down by 1. So we subtract 1 from every y value. Okay, so 0 minus 1 is negative 1. 2 minus 1 is 1. 0 minus 1 is negative 1. Okay, so those are the values we have to start with. Okay, so let's draw that in so long. Whoa, that is so ugly. Yeah, I'm going to struggle to draw a proper graph here. But something like that. Okay, and then we can just extend that on, right? And you're welcome to use a calculator for this as well if you can't easily see what's going on. Don't be ashamed to use a calculator. That's completely useful. So what you can do is you can just take this, type in your different x values, 0, negative 30, negative 60, negative 90, 30, 60, and 90, and plot your values. Perfectly fine. It might be a little bit quicker if you actually just do this without explaining how you're doing it all the time. But this, so yeah, feel free to use a calculator. That's actually just what I wanted to say. So we're going to continue this. We know that the amplitude, amplitude is 2. So we're going to have to go all the way down to negative 3, from 1 to negative 3, right? So that'll be over here, we'll have another point, over there we'll have another point, over there we'll have another point, and over here. So we'll just continue drawing this curve like that, and over here the same thing. Okay, and there is our graph. Perfect. So like I said, again, use your calculator if you want to. I prefer doing it just by moving dots around, comparing it to the original cos x graph. And I think that helps a little bit to understand how these things work. But you can always use a calculator or just work out what the actual values are and plot them in any graph. Doesn't have to be trig. Okay, right on the amplitude of 2 cos 3x minus 1, the amplitude is this value here, so that's just 2. And if we wanted to work it out and we didn't know that value, we just got given a graph, but not an equation, then we know that amplitude is equal to the maximum value minus the minimum value divided by 2. So in this case, what's the maximum value? It'll be 1. Minimum value is negative 3. And then we divide that by 2. So 1 plus 3 is 4. 4 divided by 2 is 2. Perfect. Right on the period of this. Okay, so this value here has to do with the period. That isn't the period, but it has to do with it. So what this tells us, we do need to know what the original period of a cos graph is. So standard period is 360. Now what this 3 does, it tells us it repeats 3 times for every original period. So we just take the original period divided by that b value, and that gives us our current period. And again, we could find this on the graph as well. We could see from here that's one whole revolution or one whole cycle. So from negative 60 all the way to 60. what is that distance? That distance is 120, so that is our period. Perfect. Okay, question 5, and that'll be the last one for today. Some absolute values. Solve this inequality. Okay, I'm just going to write it down to start with. X minus 5 less than or equal to 4. So what I like to do is I like to get the absolute value part, this whole magnitude thing by itself before moving forward. So I'll divide both sides by 2 to start with, which leaves x minus 5, the absolute value of x minus 5 on the left, and then on the right it leaves 4 divided by 2, which is 2. Now what we can do here is we know negative of this thing is equal to that, or positive of this inside is equal to that. So the positive thing I'll start with, so just x minus 5 less than or equal to 2, or negative of x minus 5 is less than or equal to 2. Okay, so we can take the 5 over, add 5 to both sides, and we get x is less than or equal to 2 plus 5, 7. Or multiply the, let's actually divide both sides by negative 1. So we get x minus 5. And if we're dividing or multiplying by a negative with an inequality, this sign has to change around. And 2 divided by negative 1 is negative 2. So add 5 to both sides. So x is greater or equal to negative 2 plus 5, which is 3. Okay, so x is bigger than 3 but less than 7, so we can combine that into a single inequality. X larger than 3 but less than 7. And there we go. Okay. Last one for today. Solve this equation. Okay, I'm just going to write it down again to start with. So 4 to the power 1 minus 2x. Oh, this looks so strange. So 1 next to the absolute value sign. That's going to be confusing. Equals 2 to the power 4. Okay, so if we can make the bases the same, then we can say the exponents must be equal. So 4 we can rewrite as 2 squared. Right, and then 1 minus 2x in there equals 2 to the power 4. So we see the bases are the same, therefore we can say the exponents are also equal. Equals 4. And then we just solve from here. So first thing again, I'm going to divide both sides by 2 to give us 1 minus 2x on the left equals 2 on the right. And again, we know that either the positive of this equals 2 or the negative of this equals 2. So let's do the positive one first. 1 minus 2x equals 2. So I'm going to say, let's keep the 1, bring the 2 over, and bring this 2x to the other side, 2x. So 1 minus 2 is negative 1, and divide by 2. So negative a half equals x. Then we can also do the negative side. So negative of 1 minus 2x equals 2. So divide both sides. Oh, I'm going to multiply the negative in this time. So negative 1 plus 2x equals 2. I'm going to take the negative 1 over. So 2x equals 2 plus 1 is 3. So x equals 3 over 2. So those are both our options. X is a negative half or x is 3 over 2. Let's just test them to make sure. So test or check. Okay, so 4 raised to the power of the absolute value of 1 minus 2 times negative a half. And let's see what that equals. So that's trying this one now. That's 4 to the power absolute value of 1. And then negative 2 times negative a half is what? Positive 1. So that gives us 4 to the power of the absolute value of 2. And that is just 4 to the power 2, and that is 16. And 2 to the power 4 is also 16, so this does work. That one is fine. Good. Now let's try if we substitute in 3 over 2. So that would be 4 to the power of the absolute value of 1 minus 2 times 3 over 2. Close absolute value. So that equals 4 to the power absolute value of 1, and then negative 2 times 3 over 2 is just negative 3. So that gives us 4 to the power of the absolute value of negative 2, which is 4 squared, which is 16. So we see that one also works. So our answer here is x equals negative a half, or x equals 3 over 2. Good, so that's it for questions 4 and 5. And again, if you use any other methods, please leave a comment in the comment section below and let's discuss that to find what is a more elegant or efficient solution to what I did, or just something more fun, even if it takes a longer time to complete it. And I'll see you again for the next video.